All right, so we are on chapter 3.2, quadratic equations and problem solving. So our objectives are to understand the basic concepts about quadratic equations, to use factoring, the square root property, completing the square, and the quadratic formula to solve quadratic equations. Understand what the discriminant is and what it informs us of, and solve problems involving quadratic equations. Things to remember: factoring. Do we all remember how to factor? Okay. So just kind of thinking about it. If you're going to do it in your head, this is factoring by grouping. So factoring by grouping, you multiply your A term times your C term, and that gives you a value. So in this case, we get 24x squared. After you multiply your A times your C term, you're going to ask yourself, what multiplies to give me 24? There's an L in there. But adds to give me 11. So what two numbers multiply to give me 24? 8 and 3. So therefore, this splits off to become 8x plus 3x. Once it splits off, it becomes two groups of terms that you can now factor independently. So I can factor independently, and the greatest common factor between these two is 2x, and I'm left with x plus 4. The greatest common factor between these two is 3, and I'm left with x plus 4. Now you're going to find the GCF of this term and this term, and their GCF is x plus 4, and then you're left with 2x plus 3. Okay, so factoring. Now, if your leading coefficient is a 1, it makes it so much easier, and that's just because you're just now focused on the C and the B and not going to worry about the A. So this is an example of when your A is 1. So going through that, if I did A times C, I'm going to get 4x squared, right? So I'm looking for what multiplies to give me 4, but adds to give me negative 4. So what is this going to break down to be? What'd you say? So we get negative 2x, and we have plus 4x squared. I'm just doing it the long way to show you that it can be done not the long way in a second. So the GCF here is x, and I'm left with x minus 2. The GCF here is negative 2, and I'm left with x minus 2. The GCF now is x minus 2, and I'm left with x minus 2. Bam. So that's the whole process of it. But shorthand-wise, all you're asking yourself is what multiplies to give me 4, what adds to give me negative 4, and you should be able to just say, oh, that's x minus 2 and x minus 2, which equals x minus 2 squared. Okay, and the reason why you can do it quickly is because the A is a 1. Do we see that? All right, now let's get a little harder. So using factoring to solve the equation here, before I can factor, it has to be equal to 0. So ax squared plus bx plus c has to equal 0, okay? So I'm going to subtract 3, and now I have 6x squared plus 5x minus 4. And now I'm going to begin. So I have 6x squared times negative 4 gives me negative 24x squared. So I'm looking for two numbers that will multiply to give me negative 4x squared, but add to give me 5x. What kind of 8 and 3? Positive 8x and negative 3x, right? And then I'm going to bring down my 6x squared and my negative 4. I'm going to take the greatest common factor of each binomial here, and the GCF here is 2x, which leaves me with x plus 4. The GCF here is going to actually, I forgot my 3, is negative 1, and that leaves me with 3x plus 4. The GCF here is 3x plus 4. And that leaves me with 2x and negative 1. All right, if you are a visual learner and seeing it like this does not work, you have the option to create the box of it. So your first term, your last term, and then after you ask yourself, what are your two numbers? Well, my two numbers are 8x and negative 3x. And you're just finding the GCF of each row and each column. So the GCF between this row is 3x. The GCF between this row is 2, 4, I lied. The GCF between this column, the GCF between this row, this column is, and so your answer is 3x plus 4, 2x minus 1. So you have two options of manipulating the problem. So you can group it, box it. Your call. Any questions by either one? People at home, any questions about either one? Okay. All right, so use factoring to solve this equation. So we have 2t squared equals 15 minus 17. Again, remember, before you can factor, it has to be equal to what? 0, right? So before I can factor, I have to make this equal to 0. What do I need to do to make this equal to 0? If no one's talking to me, that means you guys got this, and we can just go ahead and you can start on the work. Because it's not like you haven't learned this before. Some of you may pretend that you haven't, but I know you have. All right, so now you're here. So you're looking for a number that multiplies. So your A and your C, right? So my A and my C equals negative 30t squared, but it needs to add to give me my B, which is 17. So what two numbers will multiply to give me negative 30t squared, but add to give me 17? 10 and negative 3. So I now know that this is going to become 2t squared minus 3t plus 10t minus 15. What's the GCF of each set of binomial? The GCF here is just t. The GCF here is 5, and I'm left with 2t minus 3. And the GCF, the common binomial, is 2t minus 3, and I'm left with t plus 5. Okay, now this is where with the factoring we're at. Now we're going to go back, and I just want to make sure we're comfortable with factoring. So are we comfortable with the factoring? Okay, so we factored them all. Now, did it say just a factor? And solve the equation. So once I have my factors, so I have x minus 2 squared equals 0. So now I'm going to actually solve. I'm going to say what x is. So for this to be a true statement, what would x have to be? X equals 2. Bam. Okay, here, I got my two factors. They were 3x plus 4 and 2x minus 1. And I'm going to solve for x. So that means I'm taking each one of them and setting it equal to 0. So I have 3x plus 4 equals 0. And I have 2x minus 1 equals 0. So x equals what? Negative 4 over 3, right? So one answer is x equals negative 4/3. And the other answer is positive 1/2. Okay, so these are like two-parters. You're going to factor, then set equal to 0. So last one, we had 2t minus 3 and t plus 5. So 2t minus 3 equals 0. So t has to be what? Positive 3/2. And then we have t plus 5 equals 0. So what does t have to equal? T equals negative 5. Questions, comments, concerns? None? Okay, this is going smoothly. All right, solving graphically. So solving graphically may be like, oh yeah, I'm going to just graph this and look at the x-intercepts. Well, what happens when you do that sometimes? Are they exact? Nope. Poop. Darn it. That didn't work. So if I solve it graphically and I'm looking at these values, I can estimate what it is, right? But I can't give it an exact answer with full confidence. So I can say x is approximately 0.5. X is approximately negative 1.5. But I can't give the exact value. So finding the x-intercepts. So y equals, I'm sorry, I didn't mean to write y. Well, it's 4x squared plus 4x minus 3 equals 0. So when the calculator fails me and I don't know the exact values, or I'm not sure of my approximations, then I go back to doing what I was doing before, which is factoring. So I'm looking for my a and my c is negative 12x squared. My b is 4x. So what two numbers multiply to give me negative 12x squared, but add to give me 4x? 6 and negative 2. Good job. I'm going to do, I haven't did this in a minute, so I'm going to do it again. So if you're a person who doesn't like all the work and you like to keep it organized, first term, last term, and what you said your numbers would be, positive 6x and negative 2x. So you take the greatest common factor, greatest common factor, greatest common factor, greatest common factor. So now I have my factors, so I can go ahead and find what are my approximations correct. I have 2x minus 1 equals 0. Oh, look, x equals what? 1/2. Good job. Then I have 2x minus 3 and plus 3 equals 0. And I get x equals negative 3/2. Were my approximations correct? Yes, they were. I'm so sorry. Okay, so I can actually say that's where my x-intercepts are at. When it asks for x-intercepts on your homework, it does want you to write it as an ordered pair. So this is what it would be looking for. The ordered pair. Not what x equals, but it's actually going to want the ordered pair because it said x-intercepts. How do we feel? Questions, comments, concerns? All right, word problem. The height in feet of a rock, t, seconds after being dropped, is h of t equals 96 minus 16t squared. How long does it take for the rock to hit the ground? So at ground level, what is h of t going to equal? Not a trick question. 0. At ground level, you're at 0. You're at level 0, right? So if it wants to know how long is it going to take, then h of t is going to be 0 equals 96 minus 16t squared. And we're going to use inverse operations to get t by itself. So what's the first thing I need to do? subtract 96. When I subtract 96, I get negative 96 equals negative 16t squared. What do I do next? Divide by negative 16. When I divide by negative 16, I get? It is 6. So I get 6 equals g squared. What? Are you judging me on my precious 6? It's cool. I see where you're going. So we have t squared. And what I'm going to have to do with the 6? Square root. Now, when I take the square root, I technically have plus or minus square root of 6 seconds. Right? But in real world, are you going to have negative square root of 6 seconds? No. So my solution is just the positive of it. So it takes the square root of 6 seconds before it hits the ground, which is approximately, anyone else? 2 and some change. And did anyone do it? Square root of 6. 2 and 45 seconds. There we go. I was even too lazy to type it, y'all. All right, how do we feel? Are we silent because we understand this? I don't know how to take it. Good, thank you. I got some type of feedback. All right, so, taking it up a notch. So we want to determine if y is a function of x. So in order for y to be a function of x, we're basically saying, if I was to graph what I end up with y equals, does it create a function? And so we need to get y by itself. How do I get y by itself? Can't do anything until this is moved. So I have to subtract the x squared first. So I'm left with y plus 2 squared equals 9 minus x squared. And now I can take the square root of both sides. So now I'm left with y plus 2 equals plus or minus the square root of 9 minus x squared. And then I'm going to subtract the 2. And that leaves me with y equals negative 2 plus or minus the square root of 9 minus x squared. And because of this plus or minus, y is not a function of x. And that's because when I graph, I would have to graph the positive and I would have to graph the negative, and it would end up failing the vertical line test. My graph would be like that. And what does it fail? It fails a VLT. Fails it. Was that terrible? Okay. So now let's try it again. My goal is to get y by itself. So I need to get all my y's on one side and then determine if it's a function. Y is a function of x. So my first problem is this guy. Multiply by 2. I'm going to multiply both sides by 2. Cancels this side out, and I'm left with 8y plus 2 equals x plus 2y. What's my next move? Minus the 2 minus the 2y. I'm left with 8y minus 2y equals x minus 2. So that gives me 6y equals x minus 2. So y equals is this a function? Yes. To be very specific, it is a linear. Question? None? Man, I wish it went this smoothly in Algebra 2. The power of the x is a 1. It's in slope-intercept. My slope, my intercept. Remember y equals mx plus b? Bam. All right, so reviewing from yesterday, solving by completing the square. So remember how we found the magic number? And now we're going to take it a step further instead of just solving, setting up completing the square. So yesterday we stopped at step 4. And then we subtracted 10 to find our HK. Today we're going to continue through all the steps. Step 5 and step 6. So another way of solving quadratics is by completing the square. This is utilized when factoring does not work. So when you cannot factor, then you have the option to complete the square. So the first thing we're going to do is move our C term. So I'm subtracting 2, and that gives me x squared minus 6x plus something equals negative 2 plus that same something. So that's step 1. Step 2 is to find my plus something, my magic number that I'm going to add. So to find that magic number, I take my b divided by 2 and squared. So I have negative 6 divided by 2 squared equals 9. So I'm going to add 9 to both sides. Is b divided by 2 squared? B over 2 times a, that's your x of your vertex. So 3, I'm going to factor this, and this factors down to being x minus 3 squared equals 7. And now I can solve for x. So I'm going to take the square root, and I'm left with x minus 3 equals plus or minus the square root of 7. I'm going to add 3, and that leaves me with x equals 3 plus or minus the square root of 7 is my final answer. And that is solving by completing the square. When do you solve by completing the square? When it does not factor. When it does not factor, there's no number that's going to multiply to give me 2 and add to give me negative 6. Not possible. No questions at all? Okay. All right. So solving by completing the square when there is a leading term. This coefficient here, this 2. So the first thing I'm going to do is subtract 3. Well, not subtract the 3. 3 is fine. That step was already done for me. I was about to start factoring. 3 is already there, so I need to get rid of the 2 because in order to do completing the square, your a has to equal 1. So how am I going to get rid of this 2? Divide by 2. Divide every term by 2. So now I have x squared plus 3x plus some number equals 3/2 plus that same number. Now I'm going to find that magic number. So I call it M. Magic number equals 3 divided by 2 squared, which is just 9/4. And you're going to write it as 9/4. So plus 9/4 plus 9/4. Are we comfortable writing it as 9/4? Do we understand why we wrote it as 9/4? Okay. So then we continue. We're going to factor this. So when I factor this 9/4, remember it's just the 3/2. So what you're factoring down to is going to be 3/2. So we have x plus 3/2 squared equals, and this equals 15/4. Is that right? I did my math correct? Yeah? All right. When a binomial is written like this, what this actually means, you can leave it like this, by the way, but it can also be written as 2x plus 3 squared. These are equivalent. The denominator is the coefficient of the first, of your first term. But you can leave it like this because we're solving. Just wanted to throw that little tidbit out there. All right, so I'm going to take the square root of both sides. Square root of both sides. And that leaves me with x plus 3/2 equals plus or minus the square root of 15 over 2. And that's because the square root of 4 is 2. Agree? And then lastly, I'm going to have to subtract the 3 halves. So minus 3/2. And I can reduce this down to one fraction. So therefore, x equals -3 plus or minus the square root of 15 all over 2. Gotcha. What do you get? Magic. Or math, whichever. But yes, that's why I'm saying. All right, that's our final answer. Now, if you were to graph, you're going to get a really long decimal as your x-intercept, right? It's not going to spit out this value to you. It's not. It's like, oh, here it is. No. That's what it comes down to. And again, if you have a common denominator, you're going to write it as 1. Got it? Now, if you are horrible at completing the square, however, on your test, you do have to do each method at least once, by the way. If all else fails, if you are horrible at factoring, if you are horrible at completing the square, this guy is your backup. It's called the quadratic formula. Okay? So the quadratic formula works for everything. And it is x equals -b plus or minus the square root of b squared minus 4c divided by 2a. Hey, okay. I can't say it normal because I've been singing it since 8th grade. So here I am. And all you're literally doing is plugging in the values and evaluating. That's straightforward. I didn't do an example, but are y'all okay with that? I didn't think we needed an example. What did Ernesto say? Really? Okay. But are y'all okay with the quadratic formula? I didn't do example, by the way. So, all right, discriminant. So the discriminant is the underneath the square root of the quadratic formula, but it also can just be calculated without it. It's just your b squared minus 4ac. And your discriminant tells you what type of solutions you're going to have, okay? So if I look at my discriminant, Gio, pay attention. And so, where was I at? Here we go. If your discriminant is greater than 0, which means that it is positive, if you have a positive discriminant, then that means you're going to end up with 2 solutions, 2 x-intercepts. Make sense? If your discriminant equals 0, then you're going to have 1 x-intercept and only 1 solution. And if your discriminant is greater than, which means that it is negative, you're going to have no x-intercepts and you're going to have no real solution. They're imaginary solutions. It says none. Can y'all see it? I tried to be like faint, like it's not there. It says it, but it's like in shadowy. You get it? Yeah. Okay. That's because it's not that it's none, it's just no real solution. So there's no real solution. You have a solution, it's just imaginary. So let's do a little discriminant practice. And then we'll go through and do the full quadratic. Because we've already done the discriminant. So if I was to do the discriminant, which is the b squared minus 4ac part of the quadratic formula. Here's my b, here's my a, here's my c. So that leads me to negative 4 squared minus 4 times 3 times negative 1 equals 16 plus 12, which equals 28. So my discriminant is positive, so that means I should have 2 solutions, 2 real solutions. Does that make sense? Okay, so plugging that into the x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, so I've already did the discriminant part, and I'm plugging in my negative b, so negative 4 plus or minus the square root of 28 over 2 times 3. That's going to give me 4 plus or minus. The square root of 28 can be simplified to what? Two square root of 7. And that's because you can factor out the 2 2's of the 4. Oh, it did it on its own. So 28 is made of 4 and 7, and square root of 4, square root of 7. Square root of 4 is 2, square root of 7 is nothing. Well, it is something, but nothing we're dealing with. All right. So I chose this problem in particular to show you that if all terms have a greatest common factor, then I'm going to reduce. So all of these terms have a GCF, which means I can divide each one by 2. This answer is correct, but it is not the simplified answer. So it would not be taken as correct if you put it into your homework. This is your final answer. How we feel? Good? Oh, this is going too smoothly. I don't know if I should get excited or y'all just set me up for failure on the quiz tomorrow. All right, so person's heart rate after X minutes is given by f of x equals 2x squared minus 24x plus 192, where between the intervals of 0 and 6. Determine when the heart rate was was 128 symbolically, graphically, and numerically. Okay, so symbolically, that means that we would look at a table and analyze it. Graphically means that we would use a graph. And I think numerically, maybe numerically is table, symbolically is solving by hand. I don't know why this book uses those words, but we're gonna do symbolically, which I think is by hand. Yeah, that sounds better. So if I have 2x squared minus 24x plus 192, I don't know what just happened there. And I want to know, when is the heart rate equal to 128? Before I can start any method I'm going to try, I have to get it equal to 0. So I'm going to subtract 128. And that's going to leave me with 2x squared minus 24x. And I get 464. Okay. Now, if there is a GCF, you want to go ahead and factor out that GCF. Okay. If there is a GCF present, otherwise you're just working with bigger numbers for no reason. So my GCF here is 2. So I'm going to now be working with x squared minus 12x plus 32. So I can ask myself, before I go anywhere, I always check factoring first. So checking with factoring. Are there two numbers that will multiply to give me 32? Perfect. So I know it factors out to be x minus 8 times x minus 4 equals 0. So therefore, x equals what? X equals 8, x equals 4. Which value falls in between my interval? 4. So the answer that they want is 4. So after 4 minutes, that's when the heart rate is 128. Now, if you were struggling, could you have did the quadratic formula here? Yes. But if you take your time and use all of your skills, something that may seem a little overwhelming is actually pretty simple. All right, what happens when you are working with a fraction? So here we have 5x squared minus 4x plus 4/5 equals 0. When you have a fraction, you want to multiply everything by the least common multiple. And luckily I only have 1, so my LCM is 5. So I'm going to multiply everything by 5. And that's going to give me 25x squared minus 20x plus 4 equals 0. If you are a person who is comfortable working with fractions, you do not have to do that step. You do not have to utilize the LCM. But if you don't want to work with fractions, then use the LCM to get rid of them. Okay. It wants us to use the discriminant. So it's going to ask you, what is your discriminant? So using discriminant, y'all saw the D disappear, right? Rude. So my discriminant is b squared minus 4. I didn't do that, y'all. Minus 4, and my A is, and my C is 4. So that gives me 400 minus 400, which equals 0. So how many solutions do I have? 1 solution. So when I solve this, if I end up with more than 1 solution, I did something wrong. Okay? So looking at this, ask myself, My a times c is 100 x squared. My b equals negative 20x. So it multiplies to give me 100, but adds to give me negative 20x. Negative 10 and negative 10. So I don't have enough space. I'm just going to do the box. I have negative 10x, negative 10x. What's the GCF between these two? 2. If the outer box is negative, then the GCF is negative. What's the GCF between these two? GCF is still 5x. GCF is negative 2. So therefore, and this is why I only have one solution. OMG. And that one solution is x equals, say again, 2 over 5. Yes. So your LCM comes from your denominator. And what's my denominator? 5. If there's multiple ones, then your LCM will not necessarily be that denominator, but because there's only one denominator, my LCM is that one denominator. All right, then the rest are just more word problems and reading through using the calculator. So at this point, you would start, the word problems would be on the calculator side of your test. So you're setting it up, putting the calculator, looking at the x-intercepts, and that's because word problems are usually real world problems. And with real world, we have decimal approximation. Okay. And so that's all that we have left. Let's just going through that. If tomorrow we can go through typing and putting it into the calculator. But it's creating the regressions, which we started yesterday, talked about yesterday, but we can review it tomorrow if y'all want, before you have the first half of the class to review, work on some of your homework, and then the last 15 minutes of the class, you will take your quiz. Any questions about Thursday's plan? Okay, Friday is a full work day. So Friday is a full work day. There's no reason why anyone should have their homework turned in late on Sunday, because you will have had basically 2 days to work on it during your class time. Are we good? At home, are we good? Speak now, forever hold your peace. All right, we're done.